Hi guys, today we're going to look at simplifying more difficult exponent expressions. So we have two different types. The first one is expressions with only multiplication and division inside the expression, and then we have expressions with pluses and minuses in between, which means we are creating different terms. If we look at the expressions with multiplication and division, the first one, you'll see the dots represent the multiplication and the long line represents division. In the second expression, you'll see that we have a negative in the middle. That means there is positives and negatives in between. So let's look first at type 1, expressions with multiplication and division. I've written down the steps there. So our first steps would be to turn the values into prime factors using the column method. So how we do that is we take our first value 10. We see what's the smallest value that can divide into it, which is 2. That gives us 5, and then we divide by 5, which equals to 1. So therefore our prime factors of 10 is 2 times 5. So the next one would be the 25. So the smallest value it can divide into 25 is 5, and then we get 5, and 5 is divided by 5, which then equals 1. So therefore it would be 5 to the power of 2. And that is going to be the prime factors to get to 25. And then the last one is just 2 to the power of 1. It's already in its prime factors. Then we're going to take the value 50. The smallest value that can go into that is 2. So we're going to say 50 divided by 2 is 25. And then 5 divided by 25 is 5. And then 5 can divide by 5 once. So therefore, our prime factors would be 2 times 5 to the power of 2. And then for the last one, our 5 is already in its prime factor. So it would just be 5 to the power of x. And that was our first step. Our second step is to multiply the exponents now in. So we're going to multiply in the x with the 2 and the 5, and that becomes 2 to the power of x times 5 to the power of x. Then we're going to multiply in the x with the 2 and the negative 1 with the 2. So it's going to become 5 to the power of 2x minus 2. And then the last one is just 2 to the power of 1. And then at the bottom, we're going to multiply in the x plus 1 with a 2 and with a 5, and it's going to become 2 to the power of x plus 1 times 5 to the power of 2x plus 2. Very important that the 2 multiplies with a 1 as well, and then 5 to the power of x. Our next step is to split the bases. So the first one, the 2 to the power of x would stay the same, times the 5 to the power of x would stay the same. And then the next one would split, so 5 to the power of 2x multiplied by 5 to the power of minus 2 times 2 to the power of 1. And then when we divide, we're going to split up the 2 to the power of x plus 1 into 2 to the power of x times 2 to the power of plus 1. So we're just doing the opposite of the exponent law. And then we have 5 to the power of 2x times 5 to the power of 2. And then our last one would just be 5 to the power of x. And then our last step would to be add the exponents of the bases that are the same together. So all the 2. So it's going to be 2 to the power of x. And then we're going to add another 2 to the power of 1. So it's going to become plus 1. And then the 2's at the bottom are technically being subtracted because they are dividing. So it becomes minus x and then minus 1. And for the 5's, it's going to be 5 to the power of x. And then another one, the 2x next to it, we are going to add because the bases are being multiplied. So it becomes plus 2x. And then we're going to add the 5 to the power of negative 2. So it's going to be plus minus 2. So it just becomes minus 2. And then the 3 bottom 5's we need to subtract because they are dividing. So it becomes minus 2x minus 2 minus x. And then we just add them up. So it's going to be 2. And then we can add up the x's. So it's plus x minus x, which cancels out. And the plus 1 minus 1 cancels out. So it becomes 2 to the power of 0. Then with the 5, we're going to say x plus 2x is equal to 3x minus 2x is equal to 1x. And then minus that x is just going to be equal to 0. Then we add the values, so it's minus 2 minus 2, which is going to be 5 to the power of minus 4. And because that exponent is negative, it needs to go to the bottom. So our 2 to the power of 0 becomes 1. And then at the bottom, it would be 5 to the power of positive 4. And that is our ending answer. So let's look at the second type. Now we have expressions with addition and subtraction in between. So our first step would be to turn all the values into their prime factors. The first one, the 3 to the power of x to the power of 2, is already in its prime factors. 9's prime factors is 3 to the power of 2. So we plug that into the position of 9. And then at the bottom we'll do the same. It becomes 3 to the power of 2. In brackets to the power of x minus 1. Our second step is then to multiply the exponents in, just like the previous question. So it becomes the 2 and the x multiply, so it becomes 3 to the power of 2x minus, and then we multiply the 2 with the x and the negative 1, and therefore it becomes 3 to the power of 2x minus 2. And then at the bottom, we also multiply it in, and it becomes 3 to the power of 2x minus 2. Second step is to split the bases, so it becomes 3 to the power of 2x, it's only one base, minus, this one we break up, 3 to the power of 2x times 3 to the power of negative 2. Yet again, the opposite of the exponent law. And then at the bottom it's the same, 3 to the power of 2x times 3 to the power of negative 2. Now this is where the difference comes in with the previous question. Now we need to take out the highest common factor in the terms that has positives and negatives in between. So at the top, our highest common factor there is 3 to the power of 2x. So we take that out as a highest common factor. Then we're left with 1 minus 3 to the power of negative 2 at the top. And then at the bottom, because there's only multiplication, we'll just rewrite that part, 3 to the power of 2x times 3 to the power of negative 2. Then our next step, 5, is to cancel out the highest common factor, so 3 to the power of 2x at the top and the bottom, and therefore our answer becomes 1 minus 1 over 3 to the power of 2 divided by, because the exponent is negative with the 3, it also needs to move to the bottom, and it becomes 1 over 3 over to the power of 2. And that answer becomes 1 minus 1 over 9 divided by a ninth, and that equals 8 over 9. Divided by 1 over 9, and your ending answer would then be equal to 8. Let's look at the quick bonus question that I've added, which is expressions with fractions. Our first step would also be to first change the values into prime factors. For the 32, if we divide by 2, we'll see that it ends up being 2 to the power of 5. So we write that in the inside of a bracket to the power of 3x over 5. Then we say plus. Then we break up the 64 into its prime factors. So if we say 64, we can divide by 2. So that gives us 32. Divided by 2 gives us 16. Divided by 2 gives us 8. Divided by 2, which then gives us 4. And then 4 divided by 2, which equals to 1. So we always need to end up with the answer equaling to 1. And that would be then 2 to the power of 6 inside the brackets. And then to the power of x over 2 plus a half. So first, let's just calculate the first top part. So now we're just going to multiply the exponents with each other. Just remember that the 5 is technically a whole number, so it's standing over 1. And then we just multiply fractions. So we're multiplying the top with each other, and we multiply the bottom. So it becomes 5 times 3x divided by 5. So the 5's cancel out. So it becomes 2 to the power of 3x plus, then we're multiplying in the 6 at the top with the x, and with the 1, and then we multiply the 1 at the bottom with it both 2's. So it becomes 2 to the power of 6x over 2 plus 6 over 2. And then at the bottom, we're going to take the 243 and we're going to break it up also back into its prime factors. So 243 divided by 3, it gives us 81, divided by 3 gives us 27, divided by 3 gives us 9, divided by 3 gives us 3, and then again divided by 3 gives us 1. So please remember to look at the smallest prime factor that can divide into the number each time. So it's going to be 3 to the power of 5, and then on the outside of the bracket, to a fifth. Times, then 8's prime factors are 2 to the power of 3, so you're going to write 2 to the power of 3 inside the bracket, and then outside of the bracket the x. Now we are going to simplify the exponents. So at the top it just becomes 2 to the power of 3x plus, now we can say 6 divided by 2 with the exponent, so it just becomes 3x plus 6 divided by 2, which is 3. Then the same that we did previously, now we're going to multiply in the fractions. So the 5 at the top and the bottom cancels out, so it just becomes 3 to the power of 1, and then the 2 just becomes 2 to the power of 3x. Our next step would be then to split the bases from each other. So the first part stays the same, it's 2 to the power of 3x, and then it becomes plus 2 to the power of 3x times 2 to the power of 3 at the top. And then at the bottom it stays exactly the same, so it becomes 3 to the power of 1 times 2 to the power of 3x. Because there's a plus sign in the middle splitting the terms at the top, we need to take out the highest common factor, which would be 2 to the power of 3x. So if we take that out, what is left in brackets in the first term is 1 plus 2 to the power of 3. And then at the bottom we're just going to rewrite it that the 2 to the power of 3x stands in front, because then that would be the highest common factor that needs to cancel out at the bottom. So it's 2 to the power of 3x times 3. Then our next step is to cancel out the highest common factor, so at the top and the bottom. Then we are left with 1 plus 8, and then at the bottom over 3, and that becomes 9 divided by 3, which is equal to 3. And that's the end of our session today. Thank you for watching.